Estimating a population parameter is like aiming for a bullseye while playing darts. As much as we'd like our sample statistic to be the perfect estimate for the population value, we know that we nearly always miss by at least a little. To take the best aim possible at that population parameter, the bullseye, we carefully select a random sample doing all that we can to avoid bias. We calculate a sample statistic, the mean or the proportion in this class, which is our point estimate for the population parameter we're interested in. Adding and subtracting the margin of error provides the lower limit and upper limit for the confidence interval. The difference between them is the width of the interval as well as being double the margin of error. This illustration has an interval that includes the bullseye that represents the population parameter we wanted to estimate. But in reality, we wouldn't know that because we don't know the population parameter to check. What we do know is that the sampling distribution of either of these unbiased estimators is normal when our sample size is large enough. Our confidence level is the area of the unshaded center of the distribution and matches the width of the confidence intervals we construct. Like our target illustration on the previous slide, we can take a sample, calculate a statistic, and then construct a confidence interval. As long as we get a sample that is in the unshaded area of the sampling distribution, the interval will contain the population value. Not every possible sample will provide an interval containing the population parameter we are estimating, but we can quantify the probability that the process will provide one that does. That's the confidence level. You can see the one interval that doesn't include the center of the sampling distribution, which is the parameter we're trying to estimate. That sample value was one of the smallest possible values in the sampling distribution and missed the target. There is a common format for all confidence intervals. One sample mean, difference of sample proportions, anything else in our textbook, and all possible estimating statistics that we don't cover in this course.